So we were discussing MCQs. Only one MCQ was done in last video because we were discussing nucleic acid, phosphate was remaining, and a lot of basic concept I gave in last video with this one MCQ because time was remaining. So I've done. This is to answer why, because nucleic acid composed of RNA and DNA. RNA DNA. This means they are known as nucleotide because they are monomer of nucleic acid, and they make a long chain. Long chain. This means poly. Poly means many. So long chain would be known as polynucleotide. And yes, that's true. DNA make the DNA is a polynucleotide. So the right answer was 2. And the question, which of the following bases is not present in DNA? If you write the bases, this means adenine, guanine, thymine. One is remaining, which is cytosine. And yes, that's the 2, because in DNA you will not find uracil, but there's thymine is present. Okay, thymine is present. These both have the concept, but here still if we count 4 nitrogenous bases, cytosine is not there. So right answer here is uracil because this is present in RNA, not in DNA. This is present in RNA. Okay, let me change color. Okay, so second, which of the following bases contain 2 keto group? So you should remember 2 keto. This means like adenine, which is no keto group, we know that. Guanine and these all structure in nucleic acid heterocyclic, which means hetero means different. So this means different chain attached. If you make any structure like this, like here you will see carbon attached, here you will see carbon attached, but here you find another like nitrogen attached, here you find hydrogen, a lot of chain with different like categories. This means they are heterocyclic. So nitrogen, nucleic acid are heterocyclic as well. So adenine, which means they don't have any ketone group, this means they have no ketone group. And guanine, guanine and this one cytosine, they both have one ketone group. But when you talk about thymine and uracil, because these both are an exceptional, not exceptional, but that's the only difference between RNA and DNA, thymine and uracil. So thymine and uracil, they both contain 2 like ketone group, but in this MCQ it only asks about only like uracil is not present. So this means the right answer here would be thymine. Thymine here, C is the right answer. Here uracil is the right answer. Here C, A is the right answer. So yes, if we're very done with this, now we are going to do this one. Nucleic acid which are linked together by bond between 5 and 2 carbon of 2 different pentose sugar. By looking into this question, no need to read other like complete statement, because I'm sure you have like studied a little part of genetic. If not genetic, like this is a basic, I mean basic concept. If you don't know this, like I think this is a very very basic concept you would have known. If we have studied it, RNA DNA composed, or they make a like this kind of structure 5 prime to 3 prime or 3 prime to 5 prime. No matter if you don't know what's transcription, what translation, nothing, like you don't know anything, but still this structure is most common and you will see everywhere. So this means if they're saying 5 to 2 prime, they're like not stupid, but they mean something else. This means this exactly tells this is the false statement. Okay, then here we have another, which is the attachment between the base and sugar in nucleotide is through dash bond. This is very important MCQs, I know, and I'm sure you know this because in last video I just discussed. Let me go through that. Here is phosphate and sugar. The bond between them is phosphoester bond, but when it's come to sugar plus nitrogenous bases, the bond between them is this one, glycosidic bond. So the right answer would be here. The MCQs, here we go. So the attachment, that is okay, the attachment between the base and sugar, this means base and here is the sugar. So the bond between them would be glycosidic bond, and that's like what we just studied few seconds before. That's glycosidic bond between them. So I'm sure you've gotten these all. If not, so I could explain again.